In this video, we're going to discuss how to solve a quadratic equation by factoring, and we're specifically going to focus on a quadratic that has three terms, so what we call a trinomial. So when we talk about a quadratic equation, we mean an equation of this form. So the fact that the number a, so first of all, a, b, and c are just numbers. X is the variable. The fact that a is not 0 guarantees that we see that quadratic term, that term where the variable has an exponent of 2. It's possible that maybe b is 0 or maybe c is 0. B and c can be any real numbers, and a is any real number besides 0. So to solve this equation, where we have a quadratic on one side and 0 on the other, what we're going to do is we're going to factor the left side. And when we say factor, let's think about what we mean by that. The word factor kind of implies multiplication, right? Like 2 and 3 are factors of 6. Because 6 is equal to 2 times 3. So if we were going to factor the number 6, we could do that by writing it as 2 times 3. So when we say we're going to factor something, it means we're going to write it as a product, meaning we're going to write it with multiplication. Now we do that because then we can use this property. I'm not going to state the name of the property here quite yet. But just think about this for a minute. If I tell you I've got two numbers, a and b, and I multiplied them together and I got 0. You probably automatically know something about those numbers a and b, right? If I multiplied them together and I got 0, that means that either a was 0 or b was 0, or maybe they were both 0, but definitely at least one of them had to be 0. So if a times b equals 0, then a equals 0 or b equals 0. That's an inclusive or. They could both be 0. But at least one of them has to be 0. This is what's called the zero product property. And it has that name because this only is true for 0, right? So product means we've got the multiplication there, right? But it's the zero product property. It's so special because this doesn't happen for any other number other than 0. If I told you two things multiplied to be 4, right, it doesn't mean that one of them has to be 4. It could have been 2 times 2. So because of that, you don't want to factor, you don't want to write your quadratic as a product until you get the other side of the equation to be 0. If the other side is any other number, it doesn't do you any good to factor. If I know that two numbers multiply to be 1, well, I don't really know anything about those numbers. One of them could be 1, but it could be 2 times a half. So just keep that in mind, that it doesn't do you any good to factor when solving an equation unless the other side is 0. Okay, so for example here, right, we could start factoring the left side, but then that doesn't get us anywhere because, we don't have a product property for the number 3. So first thing we want to do is subtract the 3 from both sides. Now that the other side is 0, we can start working on factoring the left side so that we can use our zero product property. So to do this, what we want to do is we want to split up this middle term. We're going to keep the first term the same. We're going to keep the third term the same. still equals 0. But we're going to take that middle term, we're going to split it up into two separate terms. Okay, how do we do that? Because we want to make sure that, first of all, those two terms combined should be equivalent to negative 5x. And also, we want to make sure that it's actually going to help us with this factoring process. So what we need to do is we need to find two numbers that multiply to what? So here we look at the 2 and the negative 3. If you multiply those, that's negative 6. So the two numbers that we use to split up our middle term also have to multiply to negative 6. That just makes it so that we can finish this process that we're going to illustrate here in a minute. And then the two numbers also have to add to be negative 5. That's important because if the two numbers don't add to be negative 5, then we've just changed the equation. We want to make sure that when we combine these two middle terms, it would be the same as what we started with. So, two numbers that multiply to negative 6 add to negative 5. So if you think about that, that would be negative 6 and positive 1. Right? If we multiply those two numbers, we get negative 6, and if we add them, we get negative 5. So what do we do with those numbers? Remember, we're using them to split up this middle term, negative 5x. So we're going to separate it. And it doesn't matter what order you write the two terms in, but one of the terms is going to be minus 6x, and the other one is going to be plus 1x. It's always a good idea to check. If I combined those two terms, would I get that middle term that I was trying to separate? It's a good way to check that those two numbers actually do add to negative 5. Okay, from here, we're going to do a process called factoring by grouping. So grouping just means I'm going to look at the first two terms for starters, and I'm going to ignore the rest. And then I'm going to look at the second group later on. So if we focus on the first two terms, we want to factor from those terms as much as we can. So we look at what common factors do they have. Well, they both have a factor of 2, right? Because 2 goes into 2 and 2 goes into 6. And then both terms have at least one factor of x. So what we're doing essentially is we're trying to write this as a product, right? So we're kind of working backwards. So think about it this way. If we were starting with the number 10, right, and we were trying to write it as a product, how would I find this missing number here? Well, I would divide, right? 10 divided by 2 is 5. So that's how I know it's got to be 2 times 5. Same kind of thing here. We're dividing by 2x when we write it as a product. So if you take 2x squared and you divide it by 2x, 2 divided by 2 is 1. X squared divided by x is just x. And then if you take negative 6x and divide it by 2x, you're going to get negative 3. Okay, then we have a plus sign, so don't forget that. And now we're going to look at our second grouping. Now the only common factor that x and 3 have is 1, or negative 1, I guess, as well. And that's okay, because when we factor out our common factor from this grouping, we want to be left with the same expression in parentheses that we had before. So if we write this like we're factoring out that 1, now we have x minus 3 inside both sets of parentheses. Okay, so I've just copied that down here so we can keep going. So now we need to finish this process by noticing that we have this plus sign here. So essentially now we have two terms in this equation, right? Addition separates terms. And both of those terms have a common factor. Just like we noticed that 2x squared and negative 6x had a common factor of 2x, these two terms here have a common factor of x minus 3. And so what we're going to do is we're going to factor that in front, and then when we factor that from the first term, we're left with 2x, and when we factor it from the second term, we're left with 1. Okay, now we can use our zero product property. This is multiplication between the parentheses. Anytime there's no symbol in algebra, that's multiplication. So it's like before when I said, all right, two numbers multiplied to 0. What do you know? Well, either the first number is 0 or the second number is 0. And so then we can solve each of those equations for x. I'm going to skip some steps there in the interest of time. So these would be the two solutions to the quadratic. Let's look at another example. Once again, we see that it's not equal to 0. So that's the first thing you got to take care of. If you are going to be factoring, you want the other side to be 0. And it's helpful to put that linear term in the middle for when we go to split it up. Now, if there's a common factor between all three terms, like if that middle coefficient was 12 instead of 11, you could factor 2 from all three terms. You can do that if you want. You don't have to. It does make the numbers a little bit smaller when you're trying to figure out how to split up that middle term. In this case, though, 4, 11, and 6 don't have any common factors other than 1. So we're going to split up our middle term. We're going to keep the first term and the last term the same. And we're going to split this up. So we need two numbers that multiply to be 4 times 6 is 24. And they have to add to be negative 11. That's what ensures that it's equal to negative 11y. They got to multiply to be a positive, so it's either got to be two positives or two negatives, right? And it's got to add to a negative number. So we're looking at negative 8 and negative 3 here. Those would multiply to 24 and add to negative 11. So we're going to rewrite our middle term as minus 8y minus 3y. All right, now we can do our grouping. So look at the first group here. We can factor out of 4y. And that leaves us with y minus 2. And then oftentimes the question for the second group is, should I be factoring out a positive 3 or a negative 3? And I would say, think about what you want to end up with here. You want to end up with y minus 2 in this set of parentheses, because it's got to be the same as the first set. So in order to achieve that, you have to factor out a negative so that the signs switch, because right now the y term is negative and the constant term is positive. So factor out a negative 3 there. Okay, so I've just copied that here. And now we have two terms. There's our subtraction, separating the two terms. And the two terms have a common factor. So that's why you have to have the same thing in both sets of parentheses. You want that common factor that you can pull out front. And the first term then will be left with 4y. And the second term will be left with negative 3. So we have a product on the left, 0 on the right. That means we can use our zero product property and say, well, one of those factors has to be equal to 0. And then we can solve for y from there. So the two solutions would be 2 and 3/4.